In this video, I will be demonstrating about motor VSD object from machine builder libraries. A quick overview about the object. This object is used for start-stop, speed, ramp and direction control of variable speed drives like PowerFlex 525, 755, etc. The object is suitable in motor applications like fan, pump, agitator and many more. Configurable parameters like conversion constant, speed profile, speed time base gives flexibility to suit different application needs. Motor object is interfaced with power device objects to connect with wide range of velocity class devices. This also gives freedom to migrate from one velocity class device to another without affecting the application code. Virtualization of device helps in testing the application code without hardware. The object contains warnings and status indicators for quick and easy diagnostics. I have a demo application of motor VSD object here. In the logic section, you can see I have motor VSD object and PowerFlex 525 device object. The motor object belongs to the application layer managing start-stop, speed, ramp and direction control, whereas the PowerFlex 525 device object belongs to the device layer controlling the PowerFlex 525 drive. Both these objects are connected using control interface tags that are common for all velocity class device objects. Thus, in future, if I decide to replace the PowerFlex 525 drive with another drive like PowerFlex 755, all I need to do is replace the PowerFlex 525 object with 755 object with no change in the application code. In the HMI, I have a navigation object for agitator showing basic status. I'll open the faceplate now. A quick overview of the faceplate. This is the home tab with device and run status on the top with speed and direction set and actual status. Furthermore, status indicator in the bottom. The user unit displayed on the HMI can also be customized from the extended property of the motor instance tag. The settings tab is used for manual jog control of motor. You can set the speed and acceleration rate from here. If required, the jog command can be inhibited from the controller. The configuration tab contains configuration parameters. These parameters gives flexibility to suit the object for many applications. The conversion constant is the motor revolution per user unit ratio. The speed time base can be used to select the speed unit as per second, per minute, per hour or direct frequency control. User can choose to set the direction control using set direction bit or using the polarity of the set speed settings. The second page you can see the motor nameplate configuration. The configuration parameter entry can also be inhibited from motor object. The information tab shows all the warning status. The diagnostic tab shows the not ready reason of the object. From this button, you can launch the device object faceplate. I'll go ahead and launch. This is the faceplate for PowerFlex 525 device object. I'll go back to the motor VSD faceplate. The help tab shows the basic help about the faceplate. Here in this application, I have set the conversion constant as 5, which means motor has to make 5 revolutions for 1 revolution of load. Also, the speed time base is set as per minute, the profile as trapezoidal, and direction source as set direction bit. The set speed is at 100 rpm with acceleration and deceleration at 15 rpm per second. To start the motor, latch the command start bit. The command bits are internally unlatched and does not require any external logic to unlatch. I'll start the motor now. You can see the status is now showing accelerating. Also on the faceplate, you can see the accelerating icon. Now it's at speed. So you can see from the faceplate, the set speed is at 100 RPM and speed feedback also reached 100 RPM, whereas the motor speed has reached 500 RPM due to conversion constant, the set and actual direction. You can notice the frequency and output current from the device object. I'll also show the same on the device faceplate, frequency and current. Now we will stop the motor. Now the motor object is decelerating and now at 0 speed. I will demonstrate the jog forward and jog reverse. For that, open the settings tab. The jog function has its own set speed, accel and decelerate. To jog forward, press the jog forward button. Upon release, the motor object will decelerate and stop. Same applies for jog reverse. I'll demonstrate how the virtualization works. To change the device mode to virtual, latch the command virtual bit. You can notice the status virtual also on the device object. The faceplate also indicates the device is in virtual mode. In virtual mode, the device object will disconnect from the physical device and simulate all the status. I'll go ahead and start the motor. You can see the object is now running, but there is no output current as the physical device is not running. We'll stop the motor now. To change back to the physical mode, latch the command physical bit. Now we are back in physical mode. The motor object status ready must be on before start command is given. The not ready reason can be viewed in the HMI Diagnostics tab and also the status be not ready parameter. The not ready reason can be device, parameter setting error, or external ready input. The external ready input can be connected to user logic to prevent motor from running if the conditions to run are not met. If the external ready input condition fails while motor is running, the motor will be stopped. I'll demonstrate the not ready status by making the acceleration rate parameter as 0. You can notice the status ready bit is now off. The not ready reason is also indicated in the status be not ready parameter. Also on the faceplate, you can notice the set accelerate is indicated as not ready reason. I'll put back the original value now. The warning reason can be viewed in the faults tab and also the status B warning parameter. Any parameter entry error happening while motor is running will be considered a warning and the parameter will not be applied into the logic. This helps the user to fix the parameter error without interrupting the operation of machine. Few more warnings that can be used in the machine sequence are motor fail to start or stop and external interrupt to device while motor object is running. To demonstrate warning, first I will start the motor and then make acceleration rate parameter as 0. You can see the motor object is still running but showing a warning indication. Status B warning can be used to understand the warning reason from logics. In the HMI, you can notice the warning status as set accelerate. Also, there is a warning indication on the navigation object. I will enter a valid input now. You can notice the warning status is now cleared. In this section, I'll demonstrate how to instantiate motor VSD object in Application Code Manager. The ACM already has machine and device library registered. You need to download the libraries from Rockwell Automation Product Compatibility and Download Center page. I have already created a project and added the controller and display. I have also added a program in which we will add the motor VSD implementation. To add the motor object, right click on the program and click Add New. In the filter, we will enter motor. Select motor VSD object. We will name the object as agitator motor control. The routine name and tag name can be left as default or can be customized. The speed units have a couple of choices as RPM, RPS, frequency or user defined. If you select user defined, then you have a choice to enter the user unit name as well as the speed time base as per minute, per second or per hour. For this application, we will just select RPM. The speed profile has two options, trapezoidal or S-curve. The direction control also have choices as set direction input or set speed polarity. The motor nameplate details can be entered here. For the object callout selection, you can choose from the list. For our application, we will select as agitator. Select the display where the navigation object will be placed. Go to next tab. The first step in the link library is to create a device object. Click on create new instance. We get a choice of velocity class drives in the device library. I'll select PowerFlex 525. Click next. We'll name the object as PowerFlex 525 motor 101. Select the task and the program. The routine name can be left as default or we can enter the same routine name of motor VSD object so both the objects are placed in the same routine. Click next to create the link library. I'll do auto create. Now we are finished adding the device object. To create the asset object of motor VSD, click auto create. Click finish to complete the configuration wizard. You can notice we have added the agitator motor control motor VSD object and PowerFlex 525 motor 101 device object. To understand further about generating the code and display, watch the basics of ACM workflow video series. For more information, download machine builder libraries from Rockwell Automation website. Thanks for watching the video.